Let's do a quick version of the specific factors model. Let's imagine we have two countries, Brazil and Argentina, and we have two products, meat and soy, and meat and soy are both produced with labor, which is the mobile factor, L, and then meat requires a kind of land called the pampa, which is typical to Argentina, let's say, and soy requires a kind of land called the llano, or the plains, which, let's say, is relatively abundant in Brazil. So both countries have pampa and llano, but Brazil has relatively more llano, and Argentina has relatively more pampa, and they both have labor. So we won't worry about their relative amounts of labor. Labor is mobile between the two sectors, and we draw the graph here that tells us the allocation. Any point on this graph is an allocation of labor between the soy sector and the meat sector. We have the production functions for meat and the production function for soy, and we just assume they look like regular production functions, concave with decreasing returns to scale. With these assumptions in mind, we can then draw the four-quadrant graph, where we have a graph here that however much labor we have gives us the allocation of labor to the soy and the meat sector. We have a production function for the soy sector, a production function for the meat sector, and then we can trace any point or allocation. We have three allocations here, or four allocations. There of the meat or of labor in the meat or soy sector. If our allocation is here, we go up and see how much soy produced, and that's and then how much meat is produced, and that's one point on our production possibility frontier, and then we'll have other points, and we'll have a production possibility frontier that looks like that. So basically we're mapping from labor allocations to outputs, and then to the production possibility frontier. Labor allocation to output, and then to the production possibility frontier. So that's basically how we derive the production possibility frontier. We could do that for each country, for Brazil, and then separately for Argentina. And because they have different relative abundances of pampa and llano, remember that soy production is the llano land is specific to soy production, and the pampa land is specific to meat production. Because the two countries have different amounts of pampa and llano land, they will have different production possibility frontiers. One thing to note is that the production possibility frontier is also a representation of the opportunity costs of production. The tangent line to the production possibility frontier at any point is the slope, that is the slope of the production possibility frontier, is given by minus marginal product of labor in the soy sector over marginal product of labor in the meat sector. That is how much soy you get by giving up a unit of meat. So the slope is 1 unit of meat, and then how much soy you get. So that's 1, and then this is how much soy you would get. That's the slope of that line. One way to think about that slope too is that imagine that you give up 1 unit of meat in the country. Well, how much labor then is available? Well, if you think about it, it takes 1 over MPLM, marginal product of labor in the meat sector. 1 over that is how much labor it takes to make 1 unit of meat. If the marginal product of labor is 5 for example, so that the last labor of the marginal product is 5 units of meat, then if you reduce your production by 1 unit of meat, it would be releasing a fifth of a unit of labor. So that 1 over MPLM, that amount of labor that was used to make 1 unit of meat, can go over and make soy, and that amount of labor will make the marginal product labor in soy, MPLS. So the amount of soy you'd get is MPLS times how much labor you have, and how much labor you have is 1 over MPLM. So the ratio then is how much soy you get for 1 unit of meat. Now, if demand patterns in the two countries are similar, then in autarky, the price of meat in Argentina will be less than the price of meat over the price of soy in Brazil. And that's because Brazil has a relative abundance of llano land, so soy, if demand patterns are similar, soy is going to be relatively cheap in Brazil. Meat is going to be relatively cheap in Argentina. So as long as demand patterns are similar, the prices will be lower in the product in which the country has a factor that is relatively abundant and is specific to that product. So that's the specific factors model. Gives you a basis for trade, differences in pre-trade prices, right? So that's always the basis for trade, is difference in the pre-trade prices, and those differences are due to relative factor abundances. So the country that has relative abundance in one specific factor will have a lower pre-trade price in the product that is produced with that specific factor. And so when trade opens up, since Argentina in this case has a lower price of meat, Argentina will export meat, Brazil will export soy, and they will both have gains from trade. Remember, the gains from trade are always shown simply by the two countries, each one of them being limited to the production possibility frontier before they open up for trade in autarky. And when they do open up for trade, whatever the pre-trade price ratio, we think of that as a trading line, and say if they were producing here, and the price ratio for the country is now this is the trading line. By shifting production over here, they can produce this amount A and trade along the trading line, and they can clearly attain points. All these points here on this CPC are outside their production possibility frontier, so they're better off. That's the demonstration that they're better off, the proof that they're better off from trade.